Thank you very much for inviting me today. Today I will talk about agentic AI into production with Kagent. And my name is Oswaldo Gomez. I am a lead IT expert from Roche. So one important thing to start is what is an agent? So I believe everybody nowadays is familiarized with LLMs, and maybe agents are something that are becoming more and more popular in 2025 and beyond. I mean, we're about to have a new year soon, and this is going to continue to be strong into 2026. And this is essentially like explained here. You have a user request, like, bring me a coffee. You have an LLM, which is acting as an agent, and this agent has certain tools, and it thinks and plans and then makes some action in the real world based on the user request. And that's the difference between like an LLM and an agent. The formal definition is here. It's a system that leverages an AI model to interact with its environment in order to achieve a user-defined objective. So it combines reasoning, planning, and execution of actions to fulfill these tasks. But which tools can we use to build agents? So one very popular is LangChain. It's a framework for building applications powered by LLMs, provides tools for chaining prompts, models, memory, and APIs, and it makes it easier to integrate LLMs with external tools and data workflows. The components are you have models, so you could have multiple LLMs running, acting as the brains of the agent. You can have a set of 10 prompts that are basically structured to tell the agent how it's going to act. You have chains, which are sequence of steps combining prompts, models, and tools. You can also have some memory to store and recall the conversation state, the agents, which decide which actions to take or which tool to use, and the tools. So yeah, I'm gonna go with like some definitions, so you have like a big picture of all these things, and then I will go into a live demo. So LangGraph is a very nice framework, which is an extension of LangChain, but this is for building stateful multi-agentic workflows. So anytime you have to, for example, call multiple agents and at the same time have some sort of have a state, meaning that you know what is the status, like it has some sort of like memory, so all the agents can access the state. And then there is, for example, a central agent that will decide if it has enough information. It's usually in the form of a loop, so you will go in a loop and ask if you're done with the request or not. So it's for like much complex workflows, but also is very powerful and more intuitive in some ways. So it uses a graph structure, nodes, agents, tools, and edges, and it's designed for orchestration, reasoning, and coordination between agents. And the components are nodes, which are in this case agents, tools, or logical steps. So here we have, for example, an LLM, a certain tool, and these are all the nodes. No, the edges are the control or data flow between the nodes. So, for example, here we have an LLM. It's asking it to act on the real world, and then the tool will communicate back to the LLM and say if it achieved this or not. Then we have a state, which is essentially like a dictionary in Python. It could be as simple as like and basically an object with that contains all the state of the entire orchestration, the entire workflow. Multi-agent support, so you can have multiple agents talking to each other. Um, you can control and monitor with human in the loop traces, and you have some patterns, like it could be sequential. You can have multiple things happening in parallel, or you can have a feedback loop. And this is a plot that I really like. So multi-agentic AI allows to enable both simple and complex AI applications. So on the left hand side you have LangChain, where you have input, some chain, and some output. And in LangGraph you could actually, for example, here think about, even though it doesn't show it here, but you can think about it in the sense that it's going into loops until you get some desired output. And this is what I've seen the most powerful use cases. But what are agent tools? So you can have things like, so formal definition again is a function given to the LLM, and this function should fulfill a clear objective. So a good tool should be something that complements the power of an LLM. So web search, image generation, retrieval, like RAG, and API inference interface. Sorry. So for example, you can interact with YouTube, Spotify, GitHub, things like this. One very popular way to make this sort of paradigm between agents and tools transparent and clear and unified is MCP, the Model Context Protocol. This is a standardized interface that lets AI models seamlessly interact with other external tools, data sources, and services. So here we have things like some of the functions is unified integration, um, contextual awareness, modular orchestration, which is then like efficient, scalable, and secure. And the architecture, it goes like this. You have an MCP client, which is initiates requests and communicates with MCP server. You have the MCP server itself, and then the external tools like some API, some database. So we will see some of these things in action soon. So today we will actually try to combine all of these concepts and put it into Kubernetes. And why Kubernetes is because when you are in production or when you are in an enterprise and you're no longer in a proof of concept, you need to move past, like, for example, a POC. Kubernetes, even though at the beginning might be a little bit hard to integrate, once it's it's there and the knowledge is spread, you can have a lot of you can really get access easily to massive compute in seconds when you deploy on top of a cloud provider. So Kubernetes is an open source container orchestration system that automates the deployment, scaling, and managing of a containerized application. So it abstracts away infrastructure and differences. So it provides portability, consistency, and scalability. So you can have the same definition that goes into bare metal virtual machines in the cloud, and a cluster includes a control plane, so it can manage the desired state. And this is great. It works really well, especially when you combine it with ArgoCD. So what is ArgoCD? What is GitOps and ArgoCD? So ArgoCD follows this pattern called GitOps, where because Kubernetes is it's basically the state of the server. You want to have some sort of way to know what's the state of the server, what's deployed. If you have hundreds of applications, you want to make sure your whole team knows which version is deployed where, and also for auditing and its compliance and scanning of like security. Everything is it's in a Git repo. So Argo CD allows you to implement GitOps, where you have a Git repository, you publish your definitions, and then Argo CD syncs this state back to the cluster. And it basically acts like the source of truth for defining the desired state. And Kubernetes manifest can be specified in several ways through customized application, Helm charts, plain directory of YAML, or any custom config management tools. They're also supported. And now I came across Kagent at the beginning of this year, and in KubeCon London, it was released, and I really, really liked it. So Kagent is an innovative AI agent platform which is designed for Kubernetes environments. And you can have AI agent platforms. It's think about AI agent for Kubernetes, and it's also empowers DevOps teams to create intelligent autonomous agents from cluster management. So we will see some of this in action right now. Okay, so now I will go into the demo, and I will start by showing you that I have created this open source, and it's you can see there's a video. You can see, for example, the quick start. You can do make install tools, make create cluster. I've already run this before, so that you don't have to wait for all the Docker images to be pulled and for this to be working. But you can see that make setup just basically hits a bash file that installs everything. And once it's ready, you can go to ArgoCD. ArgoCD is a very nice tool that helps you have a declarative approach where you have every single part of your Kubernetes cluster inside of a Git repo. And then if you make any changes, it will immediately sync it. So for example, here I have the Kagent deployed, is healthy. However, I purposely broke M3 MCP tool. And then I also have another MCP tool, the MCP SQLite back. So what happened, right? What did I do? What is going on? So what happened is that I have this Git repository, and I decided to break it on purpose so that you could see how everything is working. And the latest push that I did, and this is the part where if you have GitOps, you can see who made the last change. So you can see, wait a minute, like 4 minutes ago, somebody published something new with the commit message published wrong tag. But of course, you can imagine that in reality, this could of course be just some mistake, and it not be obviously so 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 easy to spot, but still much easier than like not having this approach. So what I can do is fix this and show you how it will behave. So if I go now back to my values file, so I will fix this here, and then I will just say fixing Argo. Of course, you have probably pre-commit rules. You need to make a nicer message, and you cannot, directly push into main, but just to show you this more quickly. And how this works is you have a custom resource definition called application. This is by the API version Argo project. So that means you have to have ArgoCD installed, and it comes with a bunch of custom resource definitions or CRDs. These CRDs ask you for things like, okay, which repo you want me to make it in sync with your Kubernetes repo cluster, which branch, where in the repo you want me to look for. Would you like me to then, how am I going to install it? Or install it with Helm? And here is the values file. And you even pass the namespace and all of these things. So that's that's this one. And now you can see that everything is still in progressing. So I can try to synchronize it again just to help it a bit. And now you can see it's healthy. So it was unhealthy because I pushed an image that didn't exist, and now I fixed that. So I will create another. I will basically introduce a very special MCP tool. So there's a data set. I work for Roche, so I really like learning about healthcare and AI and IT and all this intersection. And last year I came across Leo Selly, an incredible scientist from MIT who is working for critical data in MIT that open sourced this data set from critical care units. And this open source data set has generated thousands of research papers. And it's great, but it's a bit hard to get into. I mean, there's a lot of tables you need to explore. You need to make sure that you have a good understanding of how to work with this data set, how to make sure that you can like get the right information. Like, so this is one place where having an MCP tool and an AI agent will be amazing, right? And this is exactly what I'm going to show today. So I took the liberty of creating this tool already but how I created it is pretty simple, and it's very nice, and I can recreate it. So let me just even go ahead and delete this, and I will also delete the server that I had created for this. So the tool, in there is a UI element of Kagent that's pretty nice. So let's call this mimic demo. And then here I need to pass the URL, and the URL is composed of because we are inside of, let's go to that MCP tool and see. Let's try to figure out what is the URL. So I'm going to close some of these tabs here and let's go into the services. So you can see that there's a lot of services here, but there is a M3 service. And this M3 service is essentially going to help me communicate with the pod, right? And this M3 service is essentially something I included in the help chart. So when I have to find make use of the Kubernetes tools to communicate with the pods. So I have a service, I have a deployment, and all these things that are pretty common and standard in Kubernetes. So I'm going to use the M3 service, and this M3 service is talking to the M3 pod. And if I go to the top, you can see that it listens on port 3000 on SSE. So this gives me all the information I need. There is something you can use called intra-cluster communication. So I will use exactly that. And the intra-cluster communication is when you are, for example, this Kagent is deployed inside Kubernetes, and we are inside the same namespace, and we can essentially use this is the full intra-cluster communication, but it's pretty simple. So it's the name of the service, the name of the namespace, dot service, dot cluster, dot local, and then the port slash SSE. And I will then add the server. Once I add the server, the Mimic demo takes a moment. And now you can see that we have access to execute Mimic query, get ICU stays, get race distribution, but also more importantly, you get the database schema, so you can try to give the LLM the information about what tables are available, get lab results, get table info. So very, very nice. And now we will create an agent, and let's call it Mimic demo. We're going to deploy this on the same namespace where we have the MCP tool. And here we will add a description. Let's say demo mimic agent. We have to provide some agent instructions. And I create some agent instructions that are, basically you're a specialized AI assistant for querying the Mimic 4 clinical database. Your role is to help users explore and analyze electronic health records data safely and effectively. So this is the two core capabilities, the workflow. You can, of course, then make a version of this and keep iterating it to find like the best one. Then you need to select the model. I'm using here OpenAI ChatGPT 4.1, but you can use Olama and run it in your laptop if you have enough powerful machine. And then here is where I will add the tools for this M3 MCP server. And now I can just create the agent. Once I do that, you can observe in the UI that this tool is now being created. So if you refresh, it will take a moment for this to be ready, because there is a pod that it's starting, no? But if you wanted to reflect this in GitOps, because that's the purpose of this talk, you can go into custom resource definitions and just look for Kagent. I'm using right now Lens just to visualize everything. And you can see that I have an agent resource. And the agent resource, I have here one called 30 seconds ago called Mimic Demo. And it has essentially the name, this custom resource definition, and I can see here the prompt that I was showing you in the UI. So everything can be declared. If I copy this and put it in my Git repo, I will now be able to have agents, GitOps agents, no? Which is pretty cool. Here you can have the tools that are available to this agent, and it's referring to a remote MCP server, which we can also have a look here. So we have remote MCP servers, and I have the Mimic demo remote MCP server. And here is what I typed in the UI. This is the URL. This is the a streamable HTTP. So everything that I click there, you can now copy it and put it in your Git repo. So now it's ready, and I can ask it like a nice question. For example, find a patient, who had an intensive care unit stay longer than, let's say, 10 days, and show me their complete clinical timeline. So let's see. This is connected to a demo of the Mimic database, but I mean, it has only 100 patients, but you can imagine that perhaps this will take a little longer if it's the real deal, or you can have to have a very powerful database like BigQuery. But let's see what is going on. You can see that the first thing that happened, it just tried to get immediately information from a non-existing table. And then the MCP tool is like, hey, use get database schema to see available tables. And it was like, oh, okay. So I will use get database schema to see which tables are available. Then it actually ran the query correctly the second time. You can see here. Then it kept going, more and more and more complex things are happening. It's calling different tables. And finally it says, okay, I found one patient in trauma this time of the year. Here's the complete clinical timeline. So it was admitted at this time, discharged in this time. And you can see that there's maybe some error because it's saying 2133. So interesting, probably some anonymization is going on so that you don't really know exactly who the person was. I believe this is what's going on. But yeah, it says here admission type emergency, insurance, Medicare, language, it's married, it's white, and you know it's giving me some information about the lab results, medications administered, fentanyl, like non-nerve. I don't know, all these things that saved his life. If you want, I can provide more detail or on specific lab results over time. So you can see the power, no? I don't know. I'm not a medic, and now I'm like, looking into a patient's history, which is fantastic. Of course, I had to take training in order to gain access to this database. So on like data subjects, human subjects, but it's open. Otherwise, it's open for everyone to work with. And there is also some out of the box agents that come with Kagent that I liked. I tested a couple of them. We have Kagent, K Gateway agent, Istio, PromptQL. So I'm gonna try the Kubernetes agent, and I will break something. So I'm going to perhaps go back here and go to the values file and just try to break this again. So let's break this. Say breaking M3. So if I git push, I will now go quickly to see what's going on here with the pods. Yeah, of course I pushed, but ArgoCD, it's not syncing every second. So I can try to, hurry this up a bit by hitting here the refresh button. And now it's going to be in progressing state. So if we go here into the lens, we can see, wait a minute, like this is pending. What is going on? And it's a back-off pulling image. And Kubernetes is very smart because the new version is trying to deploy a new version, but it didn't get rid of the old one. So that's pretty smart. It's trying to it's doing what it's called a rolling update. So we won't kill it until the new one is ready. So we can ask an agent to let us know what's going on. You can imagine more complex scenarios could arise, and then you will be thankful to know quickly what's happening. Why is my Kagent namespace with some issues? Let's try to be very vague, and let's see what it comes back with. Oh, I canceled the request. What is happening on Kagent namespace? So I hit the send button without hitting cancel immediately, and let's see what comes back. So agent is thinking, no? And I'm using so now it's saying like, well, based on the information gathered from Kagent namespace, there's a deployment M3 with pods showing image pool errors. So yeah, now it's interesting because because I have ArgoCD, even if I try to it can actually heal it from here. It will try, but I will not let it. No, with this information, I should just come here because if you and then just fix it here, and then say fixing Argo again. So now I will come back to Argo and hit the refresh button again, and now it's gonna be healthy, and that's it. So yeah, that's a little bit the end of the talk. I really wanted to thank you for listening, and here are some of the references that I used. Um, Here are some of the open source contributions that I did. So this is the repo that you just saw. This is the some we are fix. I was fixing some of the documentation so that everybody can use it. And in the future, I will add the mimic to the docs and see if they approve it, so that everybody can try to play with this. Thank you so much for listening, and have a good day.